Hello, I'm Nancy and I produce the OWASP DevSlop show. Welcome everyone. We've been hoping to have Vickie on the show for a long time and she's finally here. Welcome, Vickie.
Hi, thank you so much for having me on the show.
A pleasure. Thank you for joining us. So if I got this right, we're talking about code analysis today?
Mm-hmm. So today's topic is all about how a beginner can start analyzing source code for vulnerabilities.
Okay, awesome. And our sponsor for today is bugbountyhunter.com, and they've been generous enough to give us five membership to their platform, which is a hacking platform that mimics a bug bounty program. And we also have some copies of your books to give away. And I've asked you for help to select the winners. How are we going to do that today?
Right. So at the end of the presentation, we're going to have a quiz that tests your skills about doing a security manual code review. And we're going to basically give you a piece of source code and ask you what kind of vulnerabilities are present in that source code. And if you get all of them right, then you get entered into a lottery for a copy of my book.
Excellent. That sounds great. So ready to go?
Yeah, for sure.
Okay, so first, a message from our sponsor, bugbountyhunter.com.
Today's show sponsor is bugbountyhunter.com. This hacking platform aims to become your go-to place for everything bug bounties. Practice hacking on Barker, Creative, and First Blood, fully functioning websites containing realistic bugs. Once you discover a bug, you can submit it for review exactly like you would on a bug bounty platform. Your report will be triaged and feedback will be provided to help you become a better hunter. Learn how to test for security vulnerabilities and gain the confidence you need to participate to real bug bounty programs. Visit bugbountyhunter.com/membership today and let them help you on your journey.
Hey everyone, I'm Stefania Chaplin, aka DevStepOps. I'm a solutions architect specializing in DevSecOps, app, and cloud security. We have a lot of content to cover today, and we may go a little bit past the 1 hour mark. The session is recorded and will be available on our YouTube channel for replay. Really excited to be on today's show, and I'd like to introduce my co-host, Christina.
Hey there, I'm Christina. I'm a software developer here in Miami working on Apple device fleet management. I'm the AppSec champion at my company, and a lot of what I've learned is from Vickie. I even subscribe to Medium just for her articles. So I'm super excited to be here and learn some new stuff that I can implement. Nikki?
Thanks, Christina. Hi, everyone. Good morning. Good afternoon. I'm Nikki. I am a consistent host here on the OWASP DevSlop show and a cybersecurity leader. And our guest today is Vickie Lee. Vickie Lee is a professional investigator of nerdy stuff with a primary focus on web security. She began her career as a web developer and fell in love with security in the process. Now, Vickie is a resident developer evangelist at Shift Left. We don't know how she does it, but she also hunts for vulnerabilities, writes in blogs about her adventures hacking the web. She also hosts Security Simplified, a developer education series on YouTube focusing on web security, and a podcast called Sources and Sinks. So welcome, Vickie. The floor is yours.
Hi, hello everyone, and welcome to the session. Thank you so much for taking the time to join me today. Can I start sharing my screen right now?
Yep.
Cool. And welcome to the session. So today the topic that we're going to talk about is security code analysis, or the process of conducting a manual code review to find vulnerabilities in source code in order to secure applications. And this is actually a topic that I'm really, really excited to talk to you about because, in my opinion, this is one of the fastest and funnest ways to find vulnerabilities in an application. And both in my day to day work as a developer and as a hacker, I found this skill to be extremely useful because, as a developer, if you can learn to identify vulnerabilities and security issues in your own applications, you can secure your own applications before you deploy and therefore build much safer applications. And if you're a penetration tester, bug bounty hunter, or hacker, if you can uncover the source code of the application that you're attacking, you can potentially use this as an alternate way of discovering vulnerabilities in that application. So before we start, hi, my name is Vickie, and I'm a developer and a hacker. And I'm currently working at a company called Shift Left as their developer evangelist. I'm also currently authoring a book named Bug Bounty Bootcamp that's aimed at helping beginners getting into bug bounty hunting and web penetration testing. And you can find me on Twitter at VickieLee7. So let's talk a little bit about today's agenda. I'm going to first start with what manual code reviews are and why it's important for any developer or any penetration tester to learn how to review code. And then I'm going to teach you how to prepare for a proper security code review. I'm going to first go through what the tools are that you need to conduct an efficient review. I'm also going to go over some of the concepts and knowledge that you need to know before you dive into the code in order to conduct an effective manual code review. And then finally, if you're a penetration tester or a bug bounty hunter or a hacker, and you don't already have access to the application source code, I'm going to show you how to actually find the source code of the application that you're attacking. And then the bulk of this session will be devoted to actually doing code reviews and how to actually dive into source code and start identifying vulnerabilities there. I'm also going to show you some examples, and then we're going to end the session with a quiz so that you can practice manually reviewing code as well. And let's get started. So before we start analyzing any code, it's important to know why you're actually doing it and why it's important to do it. So most application security issues are actually derived from insecure coding practices. Take SQL injections, for example. SQL injections are caused by a lack of input validation. And issues like cross-site scripting are caused by both a lack of input validation and a lack of output encoding. And issues like IDORs and missing access controls are caused by missing access control or faulty access controls. Whereas issues like server-side request forgeries or open redirects are often caused by missing or weak regex checks on redirect IP addresses or domain names. So a lot of these issues are actually really, really apparent when you dive into the source code of that functionality. And so source code review is one of the best ways to find security issues in applications because a lot of these issues are difficult to discover in a dynamic scanning perspective or penetration test. But their patterns are very apparent and often very easy to find in the source code. And lastly, I'm also a huge proponent for learning to write better code through learning how to conduct security code reviews. When you dive into source code to review a piece of code for vulnerabilities, you actually learn a lot about the fundamentals of a security issue. So this will help you become a better developer and also a better penetration tester in the end because you'll have a much deeper understanding of the vulnerability at hand. So at this point, you might ask me, what about automated code reviews, Vickie? Can we just use tools to automate this entire process? And automated code reviews are also called static analysis security testing or SAS tools. And these tools do have a place in the security process. and they tend to make the process much more efficient. But the issue with these tools is that they'll always have false positives and they're never 100% accurate. So a manual code review is always needed after you get back the SAS results in order to confirm the results to see which of the vulnerabilities that are found are actually exploitable. So I would argue that it's still really valuable to learn manual code reviews, even if you have these tools available to you. And by combining SAS tools and manual code reviews, you can make the code review process very, very efficient and build much safer applications. So let's start preparing for conducting a manual code review. Before we start the preparation section, does anyone have any questions about the material that I just covered thus far?
It's
I'm
not a
looking in the.
question. Oh,
No,
sorry.
go ahead,
I was going to
Stefania.
say
Go
it's
ahead.
not a question as such, but I think you raised some really valid points around SAST and false positives. Because
Mhm.
for those that don't know, a false positive means that if you say it's negative, if you say it's vulnerable, but then it's not, and it's like, oh, why do I have to fix this? It's not wrong.
Mhm.
And then you have on the flip side, then sometimes you have false negatives when it's like, oh, it's safe, but it's not. And I think you've really touched on it well, that you need to have, yes, it's great to have the automated ways, but you need to have the manual, code reviews just to like double check, and then they might catch things that the SAS tool didn't.
Mm-hmm. Right. So before we actually dive into how to conduct a manual code review, I think it's very, very important that um, to say that I'm not actually advocating that you dive into a piece of application source code and review the tens of thousands of lines of code yourself. But we should still learn about manual code review because first, it's SAS tools will always have false positives, and you will need to manually verify their results. And second, learning about manual code reviews will really help you understand how to use SAS tools, right? Because they help you understand how a manual code review is actually done, and they help you understand what is actually happening when a SAS tool is running and when the SAS tool actually finds a vulnerability.
Yeah, I think that's a great point. You're just educating yourself in a deeper way around, finding bugs. And then when you rely just on a tool, you sort of like, you could get a little lazy, right? You could just see what the tool says and then kind of just listen to it or not. And I feel like code reviews definitely give you a deeper way of kind of understanding what's going on. So I like that, because otherwise you get stuck in this, is the tool better or is the human better kind of discussion. And I feel like that's like a weird question to ask, right? Neither one is
Right.
better or worse. Yeah. So, yeah.
Right. SAS tools are here to help you with the process. And also, I like to add that for people that are on the more offensive side, like if you're a penetration tester, if you're a bug bounty hunter, it's still really valuable to learn how to review code manually, because once I started to learn how to read code and identify vulnerabilities that way, I learned that I find myself learning about vulnerabilities in a much deeper way. I started understanding the mechanisms behind each vulnerability. And I started to find all these different ways to bypass security controls just because I understand more how to think like a developer and how to really think about why a particular vulnerability or security issue is happening.
And I think on the developer side, it's exactly the same. When you do manual code reviews, you actually start to realize like, oh, I've made this mistake before. I've done this a bunch of times, and then you are more cognizant when you're writing your own code to try to avoid some of those issues.
Right, for sure, for sure. I do feel like after I started reviewing code for security reasons, I became a much better developer because I understand how to secure my application right now. Okay, let's continue on our presentation to the preparation of code reviews. So, first things first, before you start reviewing code, you want to make sure that you have the appropriate tools to do it, right? And the tools that are needed for security code review is actually really simple. I would just recommend that you have a good code editor or an IDE on hand. I personally like to use Sublime Text, but you're welcome to use any code editor or IDE that you like. But there's several points that you need to keep in mind when selecting a code editor for a code review. Is that first, you want to find a code editor or an IDE that allows for global searches across the entire code base. Because a lot of what we're doing during a manual code review is that we're searching for vulnerable patterns in an application, and we're often searching for these patterns across the entire code base with hundreds of thousands of files. So it's really helpful if your IDE has that functionality that allows you to search the entire application with one single search instead of going through all the files and all the different components of the application just to search for that one thing. And a second thing that you want to look for is regex searches. So a lot of what we're gonna do later is not searching for particular strings per se, but string patterns that would indicate a vulnerability. So it's really helpful if your IDE supports regex searches to support more flexible searches as well. And finally, it's good to find a code editor that allows you to cross-reference multiple files at the same time. Because when we're actually diving into searching for a particular vulnerability, a lot of what you'll be doing is that you'll be cross-referencing different functions and finding all the instances of the same function of the same variable across the entire application. So it'd be really helpful if your code editor or an IDE has like a very convenient way of allowing you to cross-reference those. And then also, I'd also recommend that you have the scripting tool or the terminal on hand just to create tests and run experiments on the code base so that you can verify your hypotheses about it. And so next, let's talk about the prerequisites concepts that you probably want to know before you dive into the actual source code. So the first thing is that it's good to understand on a high level of how the application actually works, where the critical functionalities are, like where the authentication functionality, where the authorization functionality, and what are the functionalities that deals with users' personal info and as well as sensitive info on the server. And understanding these will really help you focus your analysis on the components of the application that actually matters, right? You don't want to focus all your energy on a functionality that doesn't really matter that much for the business. And you want to focus your energy on the components where if a vulnerability is found, then the business impact will be very big instead. It's also important to understand on a high level who the users of the application are. What are the permission levels of the different users and who should be able to do what. This information will come very useful when you're testing for vulnerabilities like IDOR and privilege escalation, for example. And then finally, you want to have a high-level overview of what the major frameworks and libraries and add-ons that are in use, because these will help you identify third-party vulnerabilities that are introduced by third-party components. So a lot of application vulnerabilities are actually introduced by third-party code, not the code that you write yourself. And understanding what your application, what kind of third-party code that your application is using will come extremely useful when finding these sort of vulnerabilities. And all of this information will add up to one general picture of understanding what could potentially go wrong with your application. And that's really important to know before you actually dive into the source code, because you'll have more direction as to what you should actually be looking for. And so what if you're not the developer of an application and you're a bug bounty hunter or a penetration tester trying to identify vulnerabilities in target application instead? How do you actually find the source code of the application? So the first thing that I like to do is to actually look at the client-side code of the application instead of trying to leak source code from the server side. Client-side code refers to the code that is sent to your browser, to your client, like things like JavaScript code and HTML code. And a lot of the times, this code in itself that is exposed to the client will leak a lot of private information and a lot of the application's logic. So this would be the first place I look at and the first place I analyze. And the next thing that you could try is that you could try to um, reverse engineer the source code from the desktop or mobile versions of the application. So by definition, these applications need to be installed in your device, right? So their source code is by default exposed to the user. And if you can decompile the application and reverse engineer the source code from there, you can potentially unlock a lot of the application's logic and analyze that for vulnerabilities. And if those two methods don't work, you can always try to leak code through another vulnerabilities. Like vulnerabilities like path traversal, XSEs, or SSRFs, or any vulnerability that allows for arbitrary file reads on the server could lead to a leak of source code to the attacker. And then if all else fails, you can always utilize open source intelligence techniques like scouring an organization's GitHub repositories or going on Pastebin or Wayback Machine to look if any developers or system admins have leaked source code on these third-party sites.
Vickie, we have a question from the audience, which I think relates a bit to some of the slides. Do you need to already have extensive coding experience to perform code reviews?
I think extensive programming experience is not necessary, but it is necessary that you kind of know how programming works. You probably need to know concepts like variables, functions, etc., so that you can build a mental image of what the code is actually doing in your mind, right? You don't have to know every single detail of what the code is doing, but you need to be able to understand the logic. So that's why I recommend that before you jump into a source code review, that you actually understand at least one programming language. Like it could be any programming language, JavaScript, Python, Java. But after you understand one programming language, you probably find that a lot of the different programming languages you can analyze for vulnerabilities, because a lot of the concepts are transferable in within different programming languages.
Awesome, thanks.
Yeah, any other questions so far? Okay.
Oh, Nikki, I think you're muted.
Oh, really?
Nikki and Vickie, you're okay.
Sorry.
Nikki.
Oh, okay.
Yeah, sorry. There's a lot of questions around human versus machine scanning. So maybe as we kind of go through, this session, if we can kind of just continue to highlight the limitations of a SAS scanner and how a human is able, like the differences there, because, it's probably a topic that we can kind of go into for a while. So I think if we could just continue to touch upon it during the session, I think it'd be good. But other than that, though, I think let's keep going. And just a reminder, if you have specific questions, drop them in Slido. The YouTube chat is sort of, off to a good start here. So I don't want things to get buried. So if you have other questions, drop them in Slido.
Okay, cool. Yeah. So just as a heads up, I will touch on this issue later in the presentation, because I will be showing specific techniques that both human and machine use to identify vulnerabilities, right? And a lot of those techniques are actually the same, but there are slight differences because there's always going to be things that a SAS tool cannot do that a human can.
Cool.
Okay, let's continue then. This slide is probably one of the most important concepts and that you will take away from this presentation is the concepts of sources and sinks. So in code analysis, a source is the code that allows a vulnerability to happen, whereas a sink is where the vulnerability actually happens. Take command injection vulnerabilities, for example. A source in this case could be the function that takes in user input, whereas a sink would be functions that execute arbitrary system commands. if untrusted user input can flow from the source to the sink without proper sanitization or validation, then there is a command injection vulnerability there. And many common vulnerabilities can actually be identified by tracking this data flow from appropriate sources to corresponding sinks. And a lot of SaaS will actually work this way as well. And so let's start actually hunting for vulnerabilities. And I first like to introduce a couple of tips and tricks on how to find the most critical vulnerabilities fast. Because when you're sitting down to review your application, you don't always have the time to extensively review every single functionality and every single line of code that you've written. So it's very helpful to know how to actually find the most critical issues right away, right? So we're going to start with some tips and tricks on how to do that. So the first thing I like to do when I jump into a piece of source code is that I like to search for known dangerous functions used on user-supplied input. So a lot of common vulnerabilities actually have really predictable patterns in source code, like command injections, for example, are caused by user input being injected into functions that execute system commands. And SQL injections are caused by user input injecting into SQL queries, right? So these vulnerabilities can all be discovered by looking for these dangerous functions and see if they can be reached by the user input. So what we're going to do now is that we're going to go into an actual code base and start looking for some vulnerabilities. Just going to share my screen right here. Cool. Can you see my Sublime window?
Yeah. Could you zoom in a
Yep.
little bit if that's okay? I think I'm on a 13-inch laptop. I wish I had a huge monitor. Maybe next time.
Should I make the code bigger?
Yeah, if that's okay.
Okay, cool. Let's see. I'm going to try to make the font bigger anyway, so that we can see everything. Does everything look all right?
Yeah, I think
looks
so.
better.
Okay, cool.
Thank you.
Yeah?
Yeah.
Yep.
Cool. Sounds good. Okay, so let's start by, oh, wait, okay. Actually, let me jump back to my slides here. Let me jump back to my slides here. I do have an important link to show you guys. Cool. Yeah, so we're back. So what I'm going to show you is how to identify a command injection vulnerability in source code. And the vulnerable application that we're using is called Tarpid Java. And you can see the link of Tarpid Java right here. And if you can, feel free to download and follow along the exercises before I dive into actually hunting for vulnerabilities in source code. And Target Java is a Java application that's seeded with many vulnerabilities like the OWASP top 10, various business logic flaws, and various data leaks. So we're just gonna be looking at some sensitive info leaks and some command injection vulnerabilities and SQL injection vulnerabilities today in this code repository. Actually, can we post the link to the repository somewhere?
Yeah, I'll put it in the
Yep.
YouTube.
Cool. Thank you so much.
Drop that in.
Cool. So let's start hunting for a command injection vulnerability. So a command injection vulnerability, as I said, they often have the signature of user input being passed to a function that executes system commands without any sanitization or input validation, right? And so we're going to look for one of these dangerous functions that could signify a command injection vulnerability. And one of these functions is the function eval. So eval in a lot of programming languages would signify a command injection vulnerability because these are functions that takes in a string as the input and then executes whatever's in that string as a system command. So if you search for the function eval in the code base and you see that user input is being passed into it without any security measures, then you might have found a command injection vulnerability. So we're just gonna do a global search on this code base for the function eval. And in Sublime Text, you can do a global search on the entire application by pressing Command Shift and F. And then a window like this will open up. And you can simply plug in eval. So we're searching for the string eval and then an open parentheses because we're searching for calls to the function or method eval, right? And we're going to press enter here. So we can see that we only found one result that matches. And the result, the call to the function eval is located at servlet-tarpit.java, line 63 here. So let's go to servlet-tarpit.java here. And in line 63, we can see this line of code. What this line of code is doing is that it's getting the request URI parameter named module from the user, and then plugging it into an eval function directly without any sanitization or validation. So this is a very blatant command injection right here. And you can actually discover, a lot of the most critical vulnerabilities this way. A lot of vulnerabilities like cross-site scripting, SQL injection, and XSE can all be found by doing this kind of operation, like looking for the dangerous function and see if unsafe user input can reach it. You just be looking for different dangerous functions for each kind of vulnerability. And yeah, let's go back to our slides here.
So just a question on that. If you were in Java, like it makes sense, right? It looks dangerous, because there's no framework at play to try to help prevent some of that. But how would you approach this if there were frameworks in place here, and you'd have to understand specifically what security controls the framework might offer?
Right, that's when understanding the frameworks that a particular application uses really helps, right? Because, for instance, a lot of frameworks automatically protects against issues like CSRF, XSS, and XSE, for example. And it's important to rule those out before you actually dive into source code.
Yeah. So you should know that before. So when you look at the source code, you can kind of, makes sense.
That's like the ideal situation, I would guess. It's not always possible to understand every single detail about the security measures of a framework, right? But that would be really, really helpful and save you a lot of time.
Makes sense.
Right, and that's when dynamic testing actually comes into play, right? After you identify some issues during manual code analysis, it's always recommended that you conduct some actual attacks against the code base to verify that the vulnerability actually exists and is actually exploitable.
I have a question as well from our audience, and I also want to know as well. Are there any really cool bugs that you have found while doing source code reviews? Can you talk about such bugs and how you figured them out?
Oh yeah, for sure. So as I said, like in the previous slide, I really, really like to dive into the client-side code of an application before ever touching, before even trying to leak the server-side code, right? So I often look at the JavaScript code of an application first. And I almost always find some sensitive info leak, some credentials, or some private URLs in those JavaScript source code. So I would say like that's the number one thing I look for is sensitive info leaks in client-side code. And that's really, really easy to find with just some simple string search or regex searches.
Awesome. Thank you so much.
Yeah, sure.
Right, I'm making all the top tips. I don't do JavaScript, but that'll be tomorrow's job. Learn that, check out the client side, make lots of money in bug bounties.
Yeah, I think you'd be very surprised at how much developers actually reveal in their client-side code, because maybe they think, oh, the user won't be able to read this, or the user won't even think of reading this. But I've also seen a lot of security controls being done on the client side instead of the server side, like the CSRF token being checked in client-side JavaScript code that can just be circumvented by just changing the client-side logic, right? Or just by disabling that functionality.
Cool, awesome, thank you.
Sure. Any other questions from the audience or from you guys?
There's a lot of questions in here. Just trying.
Okay.
I guess a question: client-side code versus maybe server-side code. Is there a different approach on sort of client-side JavaScript versus server-side code that you would take in terms of looking for bugs?
Right. So my favorite thing to look for in client-side code, as I said, is sensitive info leaks, because if the application is doing security right, then they won't actually reveal a lot of the security controls on the client side, right? But on the server side, it's another issue. You can look for things like security controls being done incorrectly, or security checks being done incompletely, stuff like that. That doesn't always happen in client side code.
Right. You could also, it depends, but how it's written, but you could also kind of understand a lot more about how the underlying API works by going through the client side code. So there are things to find in there, but it is a little bit different.
Right. So it really depends. I think I've seen a lot of the instances where what should be done on the server side is done on the client side, and that allows you a lot more leeway to look for vulnerabilities on the client side code. But for client side, mostly I'll just be looking for faulty security controls, and as well as hard-coded credentials and information leaks.
Vickie, what kind of tools would you use for scanning client-side code, specifically if it's like obfuscated or minified?
So I will actually just simply use a deobfuscator first, right? How do you pronounce that? Deobfuscator first. And then I think the way I do client-side audits is actually pretty unconventional. I really don't like using any scanner tools for that. I like to dive in manually using the patterns that I've learned during my experience, like what kind of regex pattern, what kind of string patterns would indicate a vulnerability. And I just do a grep search through the client-side code. But I do know like a lot of tools actually does that for you. Like for scanning for hard-coded credentials, for example, TruffleHog is a really good tool. And there's also tools like Git leaks that will do the same thing for you. Cool. Anything else?
No, I think we can keep going.
Yeah. Okay, let's keep going then. Let's go back to our slides here. Okay, so I think we already covered this a lot in our conversation. The next thing I'll look for in source code is that I'll search for hard-coded credentials like API keys, encryption keys, access tokens, and database passwords. So these are considered vulnerabilities even if the source code is on the server side, because if the source code is leaked via some other vulnerability, then these keys, these credentials could be stolen by attackers, and that's really, really bad. And so you can search for these issues by doing the same thing that we just did. You can search for strings like password, key, access token, or and so on in the source code. But a lot of the times, these sensitive pieces of data won't be placed in variables that are named these specific names. So there's also another way of searching for these sensitive info leaks and credentials, is that many API keys also adhere to a very specific format. So you can detect these sensitive strings by looking for patterns in source code using regex searches instead. And so, for instance, AWS access key IDs commonly start with the string AKIA and then followed by 16 alphanumeric characters. So, if you can do a regex search of that string, then you can very reliably identify strings of that format and find secrets of that specific format. And a lot of API keys, API tokens, passwords, sensitive URLs, they all work this way. Let's look at an example of a regex search on the code base. Okay, so we're back at our code base here. Let's search for the string format that I just talked about, the AWS access key IDs that start with AKIA. So we're gonna do Command Shift F again, and then do AKIA 029 A to Z, and then 16. And what this regex search string is doing is that it's identifies strings that start with AKIA and then followed by 16 characters of any character within this character set 0 to 9 A to Z. And then we're going to turn on regex search here on the bottom left of the screen and then press enter. And you can see that we found a AWS access key ID and associated access key just by doing a regex search.
Cool. That was a question. Can you show an example of how you would find sensitive information?
Right. So a lot of sensitive info leaks can be discovered this way. Like, for instance, if you're looking for leaked customer email addresses, phone numbers, you can also do a similar thing. Like, you can do a regex search of a string and then an character in the middle, and then another string as a regex search, and you can identify all the email addresses in the code base.
So here's a question that I think might be a good topic for you, from your perspective. Mm-hmm. Do you actually read every single line of code, or do you grep?
It depends. So I'm actually going to talk about this a little bit later as well. So this section of the talk is all about how to find vulnerabilities quickly. So okay. We're not diving into the detailed functionalities of the application yet, but there is a way of making the actual reading of the source code more effective as well. And I will dive into that later. I'll show you how I actually audit an entire functionality if I choose to dive into that functionality.
Cool. All right, let's go.
And
Vickie,
usually,
Oh, sorry. Do you have like a repository of like regex that you use on different types of projects? Like if it's like a JavaScript project, you have like regexes that you use for that project, and like if it's a Java, you use like regex for that one, or
right, for sure. For different languages, there's definitely different patterns to look for. But for things like AWS access key IDs, like this sort of stuff, for example, the format is the same, right, across all different types of applications.
All right, cool.
And so, yeah, let's continue. So I like to just add as well that responding to Nikki's question, so when I'm auditing a piece of source code, if the application's very gigantic, I probably just read the important functionalities line by line, like the functionalities that deal with sensitive user data, for instance, or the functionality that deals with authorization or important authentication functions like logging in and accessing the database, for instance, instead of reading every single line of code and every single file line by line.
Yeah, it makes sense. You got to sort of divide and conquer.
Yeah, for sure. And that's where like tools like SAS scanning tools and SCA tools come in as well.
All right, I think we're good for now. We could keep going.
Oh, someone commented the OWASP code review guide contains a lot of regex patterns.
Oh, cool.
Yeah, I'd like to I think I'm actually gonna reference that material later on in the talk. That the OWASP code review guide is a great resource for beginners who want to continue learning how to review code for vulnerabilities.
I'll drop it in the chat too, the link.
Awesome. Okay, let's go back to the slides here. Okay, so besides the two examples that I just showed, another thing that you should look for during a manual code analysis is the use of weak cryptography or hashing algorithms. So the use of algorithms like MD5 and SHA-1 and DES on sensitive user information is a critical vulnerability that can impact the security of the entire application if not found by the developer. And these vulnerabilities are also, they're just kind of hard to find during a dynamic test or during a penetration test. So I definitely recommend you looking for those vulnerabilities in this stage. And you can look for these vulnerabilities in a very similar way like we just talked about, right? You can grab the code base for terms like MD5 or SHA-1 or DES and see if any variable names or function names are named after that algorithm. And that could be a really good indicator that that algorithm is in use at that point. And another thing to look for is to go through the dependency list of your application and search if any of the dependencies are outdated or if they're associated with any particular CVE. So a lot of application vulnerabilities are actually introduced by third-party code instead of the custom code that you write yourself. So it's crucial that you also search these dependencies and see if there are any disclosed CVEs that are associated with it. Because if an attacker find out that you're using the vulnerable version in your application, then all they have to do is to look up the CVE and then they can find the vulnerability associated with your application and just attack your application with it. So this is extremely important to look for as well. And I would argue that, SCA is just as important, if not even more important than scanning your custom source code for vulnerabilities, because so many vulnerabilities in modern applications are introduced through third-party code.
Yeah, totally. So the package.json file or whatever package management tool you're using in your source code, you should probably look at continuously.
Right. So there are tools that help you do that as well, right? There are tools that take an inventory of your application's third-party components and then regularly scan them.
Yep.
And then the next thing, and probably the final thing I look for, and if I'm doing just a quick audit, is that I will take a look at the developer comments in an application. And So as a developer, I think I can admit that I use developer comments for everything, absolutely everything, right? I use it to communicate with my colleagues. I use it to remember the things that I still need to do. And I use it to remember the details that I cannot remember, like private IP addresses or credentials and so on. And a lot of the times the developers are just using it as in like when they're developing the application, right? They're not necessarily publishing that to the public, but once this source code is leaked through the public, then these developer comments become very, very notorious for sensitive information leaks. Like you'll find anything there. Like even in even in the client side code, like JavaScript code that I've audited, I found a lot of developer comments that are there that's leaking sensitive info, even though the developer probably wanted to delete it before sending it to the client, but forgot.
I think that's worth noting as well, because we always talk about security and, applications and developers, but we are people. We're not automated machines. So like you said, you can have comments where you're just helping yourself out or trying to be more efficient. But if you forget and it makes it to production, as you said, someone could search for revealing comments. And then before you know it, bad things could happen. So I always find it interesting with security, because we talk about all these types of bugs, but fundamentally it's humans behind all of this. So it's worth kind of touching on.
Right. Actually, I have like a funny story about that. I've actually seen JavaScript source code with sensitive information leak that has a line on top, another developer comment that says, "Oh, remember, delete before production."
Well, that's good. At least the colleague was slightly on it, and then that's reality.
And then it just sort of fell through the cracks, I guess. And I think this is also why this, like looking at developer comments, looking at the comments that you wrote yourself is so powerful for the developer, because you actually understand what's going on in the application and what needs to be there, what doesn't need to be there.
Especially like things that you log to the JavaScript console. Sometimes people leave a lot of extra comments in there. So if you fire up the console, you could start to see like,
right,
why is this doing this? Somebody look at that. Or Jira tickets. I've seen Jira ticket references in there too.
Yeah, yeah. Which for the application is just horrible. But for the bug bounty hunter, penetration tester, it's like a gold mine of information.
Totally.
And so, okay, let's move on to the next phase of our review. Let's say that you have more time and you decided to dive deeper into the application's different functionalities and decide to conduct a more comprehensive manual code review instead of just, grepping through the code base that we just did. And so the first thing that I like to say is that even if you decide to do a more comprehensive audit on the code base, there's no reason to just go through every file and every line one by one. That would just take too much time, and that's often not feasible for a larger application. So I would recommend in this case that you prioritize the functionalities that you look at and you focus on the critical functions first. So these could be functions like authentication functions, authorization functions, any functions that deals with users' private information, and any functions that are critical to the functioning of the business of that application. For instance, any functionality that deals with payments, shipping, and paywalls, potentially, if the application has one. And another thing that you should pay attention to when conducting a deeper source code analysis is that you should follow any code that deals with user input. So first, look at critical functions, and then look at all the locations that takes in user input and see if they can reach dangerous functionality. We're looking at all the locations that take in user input because user input locations like HTTP request parameters, HTTP headers, and file uploads, they often provide the initial entry point for the attacker to exploit the application vulnerabilities. So tracing the data flows from these input locations to wherever they're going is also a good way to identify common vulnerabilities like stored XSS or SQL injections, shell uploads, or XSEs, for instance. So let's go ahead and take a look at a sensitive functionality here. So we're back in this window and we'll take a look at the order status.java file. So this functionality deals with a situation when a user asks the server for their order status. The application will take in a user input parameter called order ID, and then the application will query the database for information associated with that order ID and then return that information back to the user. And before we start analyzing this functionality, I'd like to take a quick poll here about what kind of vulnerabilities do you think will be present in this kind of functionality?
I've got some words I can see, like password.
Yeah.
Yeah. We could start with the usual suspects, like, not sanitizing inputs. So maybe we're just taking them straight off the get or however this is happening via a post.
Okay.
Maybe there's encryption issues.
Right.
Maybe there are.
So I think it's very important to consider the context of what kind of functionality you're auditing in this case, right? Because this is a functionality that deals with order information, like the user's order, like credit card numbers and email addresses and street addresses. So the first thing that you probably want to look for here is sensitive info leaks, right? And you can see here that this is exactly what's happening in this piece of code, is that in line 83 here, the application is creating an order object that contains all the information about the order, including the customer's email address, credit card number, and zip code, street address, and so on. And then it's actually writing it into log files. And this is really bad because then anyone who has access to the log files would get access to the user's private information, right? So this is just one example of how to prioritize your audit based on the functionality that you're dealing with. And so let's also talk about how you can trace user input to find vulnerabilities. And so we'll start from this line here. This line is a line of code that basically takes in the user input parameter called order ID. And then you can see here that down the line, this order ID parameter is inserted into a SQL query. And this is actually an instance of SQL injection because the order ID parameter, which is coming from the user, is being concatenated into the SQL query without any sanitization or without any validation or of any sort. So you can also, so a lot of vulnerabilities can be found this way by looking at a piece of user inputted data and then see if downflow it flows to any dangerous functionality of any sort.
Totally. I'm just scrolling through the chat here to look for some questions.
Yeah, for sure. We can always go back to answering questions about the code or about any of the vulnerabilities I talked about too.
I'm trying to find ones that match up to where you are so that it's a little bit more streamlined. So yeah, there's a lot of them. So there's, it's a lot of scrolling. Have any, or I guess looking for things that are obvious vulnerabilities like eval functions and things like that. How do you approach that? I guess it doesn't necessarily, well, I guess it does apply in Java, but how do you approach that Like, do you like sort of look for like obvious bad functions like string copy or things like that
Mhm.
everyone sort of knows are problematic?
Right. Yeah. I think in this case it very much depends on the tech stack as well, right? For different kinds of technology, you want to look for different things, right? PHP has several of like the unique PHP vulnerabilities that you should look for, and
Yeah,
and Java is more prone to certain vulnerabilities. So I'd say like a lot of the search strings and a lot of the stuff that you look for are transferable, but you
yeah,
also have to tailor your searches and your audit to the actual application and the technology that it's using.
yeah, totally makes sense.
Okay,
Cool.
so
Yeah, let's keep going.
yeah.
Yeah.
Okay, so you might say like, oh, this is super inefficient. I don't want to look through every single sensitive functionality that I have in my application. And you're right, actually. And doing this is very, very time consuming and could easily take up weeks or months of your time just to audit a single application. And this is where automation comes in, right? You can use SaaS tools, for instance, to automate the finding of vulnerabilities in your custom code. And you can use SCA tools or software composition analysis tools to automate the finding of vulnerabilities associated with your third party components. And then finally, you can also use a secret scanner like Trufflehawk, Git leaks, and so on to automate the finding of secrets like the AWS Access Key ID that I talked about previously. And then after you get the reports back from these tools, you can always manually verify their results to weed out any false positives that you might have. And so yeah, congrats, you made it. So that's the my presentation, and I think you now have a really good foundation to work on to learn more about code reviews. And
There's a
mhm,
there's a lot of questions around cheat sheets. Like, I
mhm.
know we brought up the OWASP cheat sheet that they have for regex. Are there any other cheat sheets out there that you find to be very useful, at least in just whether it's code specific, language specific, framework
Mhm.
specific?
Right. I do have a lot of cheat sheets that I've used in the past. Unfortunately, I cannot think of any just on the top
Okay.
of my head, but I do have a few that I can share. If like maybe after the talk, I can like quickly Google, look them up on my notebook or something and share with you guys.
Yeah. And I guess it's one of those things you just sort of accumulate over time. The more you do this, the more you're going to accumulate your own version of a cheat sheet.
Mhm.
So I mean, is that how you see it? Like, if you're a beginner, there's a bunch of questions. I'm a beginner. I've never done code reviews before. How do I start?
Right.
What would you say to them?
Right. So I would say probably begin with the cheat sheets is a good start. But over time, as you review more and more code, you'll understand more about the vulnerable patterns and what are the patterns that actually cause a particular kind of vulnerability. Then you can start actually building your own cheat sheets. Like you can actually start weeding out the things that you know don't work anymore in the current application space. And you can start building in new queries that you have found success before.
Vickie, are there any tools like any SAST or SCA or secret manager scanners that you recommend?
Mm-hmm. Right. So I think there are a lot of, in terms of open source options, OWASP have a lot of scanner tools, SCA tools, and DAS tools that can help you automate this entire process. I also don't have the links to that, but feel free to just Google SAS tool or SCA tool.
I
Okay.
just wanted to jump in, Vickie, just to say that we've opened up the quiz that you've prepared. Do you want to say a few words about that so people know what to do? I guess it's pretty self-explanatory, but I shared the link in the chat and it's also on the screen. Do you want to say a few words about the quiz?
Yeah, for sure. So the quiz is basically testing you about the material of this presentation, right? And the quiz is a simple Java file that contains multiple really severe vulnerabilities, and it's just to test you to see whether you can find those vulnerabilities based on what we talked about so far.
Okay, so we'll take a few minutes to go over Q&A. We have a lot of questions, and I'll take that time to go over the perfect scores and put that into a raffle and announce the winner. So I'll leave for a minute and come back while you continue the Q&A. Thank
Sure.
you.
Awesome. I've got a question from the audience that I'm also interested in. And you touched on it a bit about, being efficiency, but what mindset should I have to stop falling in rabbit holes while doing code reviews?
What do you mean by rabbit holes in that case?
So I'm going to say my version. That's why I actually like this question, because I know a rabbit hole really well. It's kind of like when you just there's a problem or something that you're trying to do, and then you just fall into the rabbit hole, and then all of a sudden it's 6 hours later, and you're like, wait, what? So I think it's a question, or my interpretation of the question is, how can you, really well prioritize, almost be a bit strict, or pull yourself out of a rabbit hole? Do you ever fall into rabbit holes and find it's been 3 days?
Definitely. I mean, there's isn't there this joke where you find 100 bugs in your application, and then the next day you find 101 bugs in your application, right? There's sometimes there's just no end to, finding vulnerabilities in applications, because there will always be vulnerabilities in the application, right? So I think the key is really to prioritize. For instance, you might, at the start of your code review, start by listing out a list of issues that you're going to look for and the critical functionalities that you're going to look for them in, and just focus on doing that really well first, because those are the ones that will cause major business impact, right? Those are the functionalities that are particularly vulnerable, or those are the vulnerabilities that will be really, really severe if they are found by an attacker. So you really need to prioritize on those first, instead of diving into a single functionality and just trying to find everything and everything there.
Okay, so it sounds like go in with a plan, like the cliche.
Right.
Fail to plan, plan to fail.
Here's another good question or topic. If you were reviewing code in a language that you are not immediately comfortable in, what would you do? Or how would you sort of get yourself more familiar? Somebody throws, I don't know, what if they gave you a Perl web app or something and you're like, whoa, I've never seen this. What would you do? Maybe you have seen Perl, I don't know. But what would you do to kind of get acclimated here?
Right. I actually run into that situation a lot, right? Because I'm not familiar with every single programming language out there, and I frequently need to look at applications that are written in different languages. And so in that case, I think the most important and the thing that would pay the most dividends in terms of your time down the line is that you should first learn the basics of the programming languages. You just go to the documentation page of that programming languages and just learn how their variables work, right? How their objects work, what the syntax are. And a lot of the times that's all you need to transfer your knowledge from another programming language to the current one.
Yeah. And what about mobile apps? There's a few questions around mobile app code reviews versus web app code reviews. Do you have any thoughts around the differences or how you perceive those?
Right. So actually, mobile apps are really interesting in the sense that they contain a lot of the same vulnerabilities that web apps contain. But at the same time, mobile apps have vulnerabilities that are specific to mobile apps, right? So I would say when you're auditing a mobile app, you should look for web vulnerabilities on top of the vulnerabilities that mobile apps are typically prone to. These are things like insecure session management, for instance. Hard-coded credentials are a huge issue in mobile apps, and so on, right? So I would say when auditing mobile apps, you should prioritize the easy wins, quote unquote, in the mobile apps as well, like session management and hard-coded tokens and so on.
Yeah. What about, how do you feel about newer SaaS tools like CodeQL and SemGrep? Have you used those?
I haven't used SemGrep in particular, but I do think that a lot of SaaS tools, they suffer from like they suffer from only using grep, right? I think it's very important to find a SaaS tool that incorporates the idea of sources and sinks and data flow and can do that efficiently. So like the company I work for, Shift Left, for instance, does this very well, right? The SaaS tool doesn't simply go through the code base and grab for all the vulnerable strings. They instead identify the sources in an application and the sensitive sinks in an application that correspond to vulnerabilities, and then they track the data flow between that. And that's very, very important when you're looking for a SaaS tool. You don't want something that is just a glorified grep machine.
Right.
Do
All
you have
right.
any?
Sorry, Christina, go ahead.
Oh, sorry. I was just gonna say, do you have any like particular resources for developers to use so that they could get started on practicing secure code reviews?
Mhm. Yeah, for sure. So the stuff that I talked about in this talk is really just an intro, right? Meant to get you started in the field. And you definitely need to check out more resources if you really do want to get into becoming proficient at source code review. And one of the best resources out there, I would say, is the OWASP Manual Code Review Guide. And if you can just see my last slide here, the link is actually here. It's a really good resource. It's a 200-page document about how to actually find specific vulnerabilities in source code. And that is an excellent resource to get started with. And another thing I would say is after you read some tips and some tricks on how to get started with code review, you should start reviewing some code yourself. You should find some intentionally vulnerable applications on the webs on the internet and actually try identifying vulnerabilities in that code. And a lot of these applications will have answer keys as well, right? They'll tell you where the vulnerabilities actually are. So you can verify your knowledge as well by seeing, oh, I identified this vulnerability successfully and I didn't find this one.
Yeah, we'll drop that into the YouTube chat. So make sure everyone
That would
has
be
that.
perfect. Yeah.
Yeah. And another question, I mean, it's still a bit of a softer question, but someone's asking if you ever get frustrated doing code reviews, which I think is actually a really important question.
Mm-hmm. Right.
Cybersecurity is frustrating.
Yeah.
Or it can be very frustrating. So
Right. I think that's when a lot of the automation comes in, right? It's way more fun to, try to verify like a suspicious spot in code instead of just like doing a blanket sweep on the entire code base. So I think you should really see these automated tools like SaaS tools, SCA tools as like a metal detector, right? That points you to potentially valuable things that you can then examine more closely to see if they're actually vulnerable. Yeah, I would not recommend anyone actually going through a giant application code base and just read the code line by line. Definitely use SaaS tools if you have one available to you.
you guys see any other, someone's asking a question about deep learning models. Have you ever used any like machine learning models or any sort of data science or, machine driven vulnerability kind of analysis?
Yeah, so I haven't personally worked on that, but I remember having this conversation with a colleague about what he was working on. And I think it could be like a really exciting new field for code analysis is that you allow machine learning to identify new vulnerable patterns and to identify new classes of vulnerability, right? But I don't really personally have extensive experience with that.
But you do have extensive experience writing a book, and that's another question we have, which is, let me read it directly. What tips would you give to somebody who wants to start writing a book? Any tips or best practices that you use to write yours?
So writing my book was a very, very extensive process. And I think the best way to go, I would say, is to not rush it, right? To slow down and really build out the structure of what you want to talk about in the book, right? for instance, for my book, I thought about, oh, what are the vulnerabilities that I want to include, and what are the different details that I want to include in every single vulnerability, and to really map that out in the first place, to have a structure for your writing. And then after having that structure, just slowly write out all your thoughts about that topic, and not so I think that not rushing it is really, really important, because you can get really frustrated when you're trying to take on such a massive undertaking like writing a book, right? So it's really important to have a structure, pace yourself, and do it slowly by slowly, I would say.
Yeah. And didn't you write a blog post about that? I think I've seen
Right,
you write a blog post about your approach
right.
of writing your book.
I did write a blog post about my writing process, and you're welcome to check it out. It's on my Medium blog. And yeah, it sort of documents the technique I use to really map out what I want to do with the book.
Excellent. So I just wanted to jump in again because we have our winners, the 5 winners of the book and the membership to bugbountyhunter.com. I'll put them back on the screen. They're Veda, Juan, Ili, Mac, and Alan. I have your emails because you had to enter that in the quiz. And if it's valid, you should get an email from me soon to not only give you access to the subscription for bugbountyhunter.com, and also a copy of Vickie's book that is not out yet, right? It's coming out in August. So
Right.
we'll pre-order it for you. I may need to get in contact with you to get some more information about that with the winners. We also had a raffle going on our YouTube channel, and Kaylin is the winner of that. So
Congrats, everyone.
Congratulations.
Lots of winners. Yeah.
Good job. Good job. Thank you, Vickie, for the quiz. That was fun. Yeah, I'll let you wrap up.
Awesome.
Cool.
Well,
There's a
oh my
lot of
God.
extra. Yeah. No, I just wanted to say there's some new questions, which are Vickie rocks. Great session. Love Vickie. So I just want to share those.
Thank you so much, everyone.
I was about to say the same thing from a personal level. Thank you so much, Vickie. It's been awesome. The way you answered about your book totally makes sense, because in terms of this presentation, amazing structure. Like you told us, look at, you need certain tools. What are the prerequisites? Looking at code, looking at front and back end. I didn't know you could regex in Sublime, so I'm going to start doing that now.
Mm-hmm.
So it's been really, really, really helpful. I've learned a lot. And yeah, any other words from anyone else in the team before we wrap up?
No, this is great. Thank you so much for being here, for walking us through this. I think everyone learned something today, so thank you.
Yeah, thank you so much for having me today and taking the time to sit with me to talk about code analysis.
Vickie, will your slides be available anywhere?
Sure. How about I send it over and we can publish it in the YouTube?
Sounds good. Thank you.
Sounds good. Thank you so much.
All right.
Okay, so Vickie, did you want to talk about in 2 weeks?
Yeah, in 2 weeks, we have Occupy Babel, our next show. LangSec explained in a few slogans. So it's going to be a good one for those who are interested in LangSec. So you can sign up on our meetup page, usual stuff, and we'll hope to see you there.
And Christina, do you want to talk about this?
Yes. So I will be doing a workshop in July, walking people through getting started with Hack the Box, learning about the hacker methodology, everything from pre-exploitation to post-exploitation. And yeah, just come on by.
Perfect. So last note is that there will be right here Developer Security Summit on July 24th, and OWASP just opened the call for paper. So it'll be open till July 12th, I believe. So it's the first time they had that kind of event. So if you didn't know, OWASP DevSlop is an OWASP project. So please go check out OWASP.org and the CFP if you want to talk security at our next event. So I think that's all. Thank you, everyone, and see you in 2 weeks. Bye.
Thanks,
Thanks.
everyone. Bye.
Bye.